Hello, everybody. I am honored to discuss my work with you. The subject of my presentation is a unified framework for multiple spectral clustering, which is divided into four main sections. The first part will give some brief introduction on the background, which are related to my work. The second part is going to have a brief introduction of multiple spectral clustering, which is the main source of my work. In the third part, it is my recent work. I propose a new multi-view spectral clustering method, which can directly obtain clustering results without performing k-means clustering. As you will see in the fourth part, the proposed method obtains encouraging results in terms of clustering accuracy. With the rapid development of internet and communication technology, the accesses to extract data are dramatically extended. That is, data can be collected from multiple sources. In such setting, each data is associated with much richer information, which results in the requirement that to mine the intrinsic and variable patterns hidden in the data. Hence, it is necessary to take full advantage of the information contained in multiple sources. For example, web pages can be described by both the page contents and the hyperlink information. For images and videos, color information and texture information are two different kinds of features, which can be regarded as two-view data. In web page clustering, there are often two views for describing a given web page: the text content of the web page itself and the anchor text of any web page linking to this web page. It is significant to make good use of the information from different views. A well-designed multi-view learning strategy may bring performance improvement. Multi-view clustering, in essence, involves utilizing multiple views of input data to partition instances into different clusters. Most existing algorithms for tackling this issue can be roughly grouped into co-training style methods, multi-kernel learning methods, matrix factorization methods, and multiple spectral clustering methods. Co-training style algorithms are investigated under the consideration of multiple view consensus. This category of methods intend to maximize the mutual agreement across all views and arrive at their broadest consensus. The general procedure of the conventional co-training algorithm is shown in Figure 2. According to the procedure, the algorithm is trained alternately in order to maximize the consistency of two distinct views by using prior information or by learning knowledge from each other. Note that the success of co-training mainly assumes that all views provide learning labels in condition independence, while in practice, it is usually too hard to satisfy the conditional independence assumption. As kernels in multi-kernel learning naturally correspond to different views, multi-kernel learning has been widely applied in order to deal with multi-view data. The general procedure of multi-kernel learning approaches is shown in Figure 3, where different predefined kernels are used to deal with different views. Then these kernels are combined either linearly or non-linearly in order to arrive at a unified kernel. In this paper, we mainly focus on the multi-view spectral clustering method due to its dominant advantages in clustering precision. In a multi-view scenario, data objects are captured by multiple graphs. A common assumption is that each individual graph can capture the partitional information of the data, while all graphs have the same underlying clustering structure of data. Thus, these graphs are able to mutually reinforce each other by consolidating the correlation between the data objects collectively. Figure 2 shows the pipeline of multi-view spectral clustering method, which first learn a fixed common affinity matrix of all the views from the original data, and then conduct k-means clustering on the resulting common affinity matrix. However, such a two-step strategy leads to some disadvantages. The two-step strategy is not able to output reasonable clustering performance, since the goal of the first step is not designed for achieving the optimal clustering result. In practice, such a separate screen is not guaranteed to achieve jointly optimal result because of the loss of useful information. Another disadvantage in many multi-view clustering methods is that they equally consider each view, so that they ignore the individual importance of each view. Actually, different views have various importance. Moreover, noisy views may degrade the clustering performance. And to the best of our knowledge, there was hardly any multi-view spectral clustering models outside the framework of two-step paradigm. To address the above issues, our paper designed a novel unified framework for multi-view spectral clustering method to integrate the common affinity matrix learning and discrete label learning in a framework. We further propose to automatically learn the weight of each view to avoid the influence of noise views, while assigning the uninformative view with small weight and the informative views with high weight. The proposed method integrates three learning processes into a unified framework. That is, learning the consensus affinity matrix, learning the spectral embedding, and recovering the indicator matrix. In our experiments, we compare the proposed method with 7 algorithms. As you can see, our method achieves state-of-the-art clustering performance. This indicates that the learned consensus graph of our method is a more accurate graph, and also shows that a good multi-view clustering method should consider different clustering ability of different views and adaptly assign weights for each view. And that's all. Thank you.